Okay, so we'll begin with differentiating monomials, which are polynomials that only have one term. So for example, x to the 5 or x to the 7. And we'll start with the rule on how to differentiate x to the n. And the rule is that the n comes down and then you minus 1 off the power. So the derivative of x to the n becomes nx to the n minus 1. And that's it, that's the rule. And we won't be proving it in this lesson, we'll be just learning how to apply it. So for example, to differentiate x to the 5 comes down and you get an x, and then you minus 1 of the power, so you get 5x to the 4. And to differentiate x to the 7 comes down and then you minus 1 of the power to give you a 6. Okay, next we want to differentiate 6x cubed, and we see here there's a number in front of the x cubed here, and what happens is the 3 will come down and multiply the 6, so we're going to get 18x, and then you just minus 1 of the power. The same if there's a negative, so here we have negative 4x squared. The 2 will come down, multiply the negative 4 to give you negative 8, and then you minus 1 of the power to give you x to the 1. But then usually anything to the power of 1, it's still an x, so we don't normally write the 1. So we can just simplify this a bit and write minus 8x. And normally when you want to differentiate a square term, you go straight to that step. You can miss out this, you don't need to put a 1. Okay, next we have a fraction in front of the term, so we have 1/3 x to the 7, and it's still the same rule. The 7 will come down and multiply the 1/3 to give us 7/3 x to the 6. Next we have a decimal, 2.3 x cubed. Same rule, the 3 comes down, multiplies the 2.3 to give us 6.9 x squared. And even if there's a third, so we have root 5 here, so the derivative of root 5x to the 8, the 8 comes down, so we get 8 root 5, and then x to the, and you 7 minus 1 of the power. And the last example, we have pi x to the 4. So pi is an irrational number, it's actually a transcendental number, but it's still the same rule. The 4 will come down and multiply the pi, so we get 4 pi x cubed. Okay, next we're going to differentiate linear terms, and these are terms that are x terms. They don't have any powers, so it's x to the power of 1. So for example, we have 4x or minus 7x. So the most general linear term, ax, where a is any number, let's differentiate that. So what we're going to do, we're going to add a little 1 over there, because x to the power of 1 is x. So you can always add a 1 onto the x, and now we can just use the previous rule. So the 1 comes down, multiplies the a, so we get a, and then you minus 1 of the power gives you 0, and x to the 0, anything to the power of 0 is 1, so this is just a times 1, which is a. So the rule is when you differentiate ax, you just get an a. The x cancels, becomes a 1. And in general, you'll just, from here, you'll go straight to this step. You don't need to put all the middle steps. So for example, if we want to differentiate 4x, it just becomes a 4. That's it. If you want to differentiate minus 7x, the x cancels, becomes a 1, and you just get a minus 7. if you want to differentiate x, we just have to be a bit careful here. The answer is 1. But many people sometimes in the beginning they put a 0 because it looks like, in this example, it looks like the x just disappeared. It seems to be disappearing, in which case why doesn't it just become a 0? But it didn't actually disappear. As you can see, the x became a 1. So this x becomes a 1. You can also see it this way. You can always put a 1 in front of anything. So that's the same as 1x. So if you're going to differentiate 4x becomes 4, then 1x becomes 1. So make sure you don't put a 0 when you differentiate x. And in this example, we have a fraction, so the derivative of 3/4 x. And it's the same rule, just becomes 3/4. Okay, next we're going to differentiate constant terms. And constant terms are the terms that don't have any x's in them. So for example, here's a polynomial, x squared plus 2x minus 5. The minus 5 will be the constant term. It doesn't have any x's. The 2x will be called the linear term, which you've done previously, and this is the quadratic term. So how to differentiate it? What does it become? It becomes a 0. So it's very simple. They're all zeros. But I just want to illustrate why it becomes a 0. So we should know that x to the 0 is 1. So in order to differentiate this, I can add an x to the 0 in there. So let me just rewrite that. So that becomes the derivative of cx to the 0. They're the same things because that's just c times 1. They're identical. But now we can use the previous rule. So the 0 comes down and multiplies the c to give us 0. X, and then you minus 1 of the power gives you a minus 1. But then 0 times anything is always 0. So the derivative of c, where c is any number, is 0. And in general, we can miss out all these steps. We just go from here directly to there. So if we want to differentiate 7, just becomes 0. The derivative of minus 12 will become 0. And root 6 is still a constant, so that becomes 0. And 2 pi is also just a constant, so that becomes 0. Okay, example number 1. And here we have a polynomial, x to the 5 plus 2x to the 4 minus 4x cubed plus 3x squared plus 5x minus 7. And we need to differentiate it. And the way we do it, we just simply differentiate each term separately and put pluses or minuses. So x to the 5 comes down and you minus 1 of the power. Then you have plus, then the 4 comes down, multiplies the 2 to give you 8, and you minus 1 of the power. 3 comes down, multiplies the 4 to give you minus 12, x, and then you get a square. And then the 2 comes down to multiply the 3 to give you plus 6x, and then that 2 will become a 1, but we don't write the 1. And then the 5x is a linear term, so that just becomes 5. And the minus 7, that's a constant term, that will become a 0. Okay, example number 2. And here we have a polynomial. And this has some decimals, has a pi there, there's a fraction, and there's a surd. But it's still just a polynomial, and when you differentiate it's just the same rules. The powers come down and multiply the numbers. So we can begin term by term. So the 4 comes down, multiplies to 1.2, that gives us 4.8 x to the 3. The 3 will multiply the 5 pi to give us 15 pi x squared. The 2 will come down and multiply the fraction, the 3/5. That will give us minus 6/5 x. And the root 7x, that's a linear term. So that just becomes minus root 7. And then the plus 8 is the constant term, that will just become 0.